It's been a long day for you all, I know this. And we have the next 45 minutes to discuss a topic which is, of course, related to Arctic because we are here at the Arctic Circle India Forum. But we'll be looking at the Arctic from outer space. We have discussed so much about the potential of the new sea routes coming up, several new economic activities flourishing and growing in the Arctic. And all of these activities, these new economic activities, would demand companies, governments, not-for-profit organizations, along with that, international coalitions of industries to look after something known as their ESG goals. They'll have to comply with factors such as emissions, keeping a check on emissions, ensuring that all the ships that are traversing through the Arctic Ocean, be it container ships, commodity ships, passenger ships, they are well connected through and throughout because these are very high northern latitudes. And northern latitudes classically have been less observed and less investigated for the very reason that, especially with satellites that go in polar orbits, they tend to move very fast over the poles, and a lot of their distance is covered over the lower latitudes, which is towards the tropics and the equator. So it is the laws of physics which have prevented Arctic observation for a very long time, but not anymore. Today you have several ground stations located in the Arctic. We have Martin Skedsmo with us who will discuss that. Today we have space agencies from all over the world looking at the Arctic cryosphere, looking at the flora, the fauna, the emissions, the impact of climate change. We have Dr. M.V. Ramana discussing that. Arctic skies give you tremendously beautiful auroras. Up in the north, also in the southern skies, we have Dr. Dimri, who would discuss on the geomagnetic phenomenon that his institution and his community, the geomagnetic community which is studying. And last but not the least, we have Dr. Ranjana Kaul. She needs no introduction for all those who follow space law or space affairs in India. She'll be talking about implications of international laws, especially when it comes to the regulations in outer space. So I'll first let Madam Kaul open up the session with your intervention. Ma'am?
Well, my intervention is just this, that everything on Earth, Arctic included, Antarctic included, and our own country included, is entirely dependent on outer space. I think this has been said ad nauseum for many years now. And it is therefore important for us to be very mindful about exactly what those regulations are and what is possible and not possible within those frameworks and within cooperation and bilateral relationships that countries have. And I look forward to this discussion with you and my colleagues over here. Thank you.
Dignitaries, colleagues, Varat, thanks for giving me this opportunity to discuss observations from space. Arctic has a very unique positioning in globe. For we people who are researchers, I'll not touch upon geopolitics. I know there are better players here who handle that well. Atlantic in oceanic scale through Atlantic meridional overturning circulation touches upon various continents, right from Arctic coming to lower latitude, having a 7-year cycle, goes back. So it takes information from one place to another place. I'll not go in specific details. In case of atmosphere, we have a northern Atlantic oscillation. When it's a positive oscillation, we have impact on Indian summer monsoon. When we have a negative oscillations, we have almost winter western disturbance, we call it the Indian context. which supplies winter rain. And Northern Atlantic Oscillation, because of the heating, is kind of coming to down latitudes in recent decades. So the circulation churning across is bringing a lot of vortices in various continents. Coming to upper atmosphere, as Earth magnetic field, absolute magnetic field, goes inside the geographical North Pole, which is magnetic South Pole, right? It's a 11-degree declination. And in present time, we found that magnetic anomaly is shifted from Siberia, in Canada to Siberia. So all of us uses Google Maps to locate the direction. So that will get impact in communication, aviation, and then in ionosphere, how satellite is instrumental. I have to be brief in first round? Okay. So how this instrument is instrumental for impacting the Earth's magnetic field with the exoplanet, our planets, and rest maybe a bit in detail in later time. Yes.
Thank you. Over to Martin.
Okay, thank you for inviting me to this conference. Happy to be back in India again. When I left Tromsø, it was snowing. It's in the Arctic, so it's a huge difference to arrive here in a total different climate. Kongsberg Satellite Services, we've been dealing with satellites for more than 50 years. We talked to our first satellite back in 1968 on the 17th of May. And since then, we have been developing the antennas to be able to communicate with all kinds of satellites. We are located in Tromsø, but we also have the world's largest commercial antenna station in Svalbard with close to 170 antennas. So the question is, why do we have this in Svalbard? Well, most of the satellites we use for environmental monitoring, for such as things as oil spill detection, vessel detection, ice monitoring, we use polar orbiting satellites, meaning that they use around 90 minutes to orbit the Earth. Every time they pass over, they have to pass over Svalbard, meaning we get to talk to the satellites every single time they pass. They pass 16 times during 24 hours. We're also able to talk to all kinds of satellites, radar satellites that we use to be able to look through clouds, use them if it's dark outside, which is normally half of the year up north, to be able to look for vessels in need, ice-infested waters, if we have vessels there, oil spills, for example. So this is something we have been doing since the late 60s, and expanding our antenna capacity, both on Svalbard, but we also have a station in Antarctica and some 26, 27 other stations around the world. So we've been dealing with satellites for basically environmental monitoring for many, many years.
Thank you. Dr. Ramana from ISRO.
Yeah. The direct consequences of Arctic melting are sea level rise and thawing of permafrost. To directly or precisely measure the sea level rise, way back in 2013, ISRO joined hands with France and launched Sierra-Altica mission. It was then the unique machine, satellite, which is a Ka-band radar-based altimeter, and it provided the precise measurements of sea level rise. Now ISRO is in the same lines, joined hands with NASA launching NISAR, NASA ISRO synthetic aperture radar, and it is going to provide continuous data over polar regions, and it is going to cover entire Arctic and up to 80 degrees in the polar regions, in the Arctic region. And it is going to provide varieties of parameters related to the Arctic, especially essential climate variables. And coming to the permafrost thawing, permafrost, and release of greenhouse gases and all, India committed in G20 to launch a G20 satellite exclusively for atmospheric composition. Now India or ISRO is in dialogue with G20 nations to come up with a unique another satellite to measure exclusively for atmospheric composition measurements. On top of that, ISRO has several sensors for radar imaging, satellite sensor instrument, and optical based sensors, which are providing changes on the Earth surface as well as the changes in the atmospheric composition. But the most important point is I wanted to stress here is um, continuity of the investment. We need to have continuous measurements. That is what it is lacking. So the point here is to pay attention is the continuity of the measurements and the consistent funding to maintain these sensors. Thank you.
Thank you. The purpose of this session has been to understand the fact that, at the Arctic Council, especially in 2017, an agreement was conceived. That agreement is called as the Agreement on Enhancing International Arctic Scientific Cooperation. And as part of that, sharing of satellite data, especially scientific data, for ensuring sustainability in the Arctic could be one of the agendas. When I say could be, I mean that this particular aspect of the scientific cooperation is yet to be tapped. Now, with the great efforts invested by Arctic Circle to go around the world, we are very much pleased that they are in India this time. And since we love space activities in this country so much, we thought that let us sort of plug in this particular idea that, hey, all the countries or all the representatives of countries that have gathered here, let us think about sharing of these data sets in the interest of science as well as in the interest of business and economics. Because if there are economic activities going to happen in the Arctic, then we must ensure that these are scientifically grounded. These activities are scientifically, made sustainable. And for that very reason, I want to push across a question to my esteemed guests here. My first question is, are there existing multilateral mechanisms that you have encountered where sharing of data related to Arctic has been conceived? Could you throw some light on that, ma'am? Yeah, to all of you.
Well, no, I have not come across any such treaty that particularly focuses on the Arctic. What we do have very extensively, in fact, from 1961, where for the first time the United Nations recognized that there is going to be an impact on the environment of the Earth as a result of space activities. And that was the time when the WMO and the UNESCO were amongst those international organizations that were brought together within that fold. And the UN COPUOS was asked to prepare reports and to submit these to UNESCO and to the UN General Assembly. So the impact of human activities, although it is satellites, but humans sending them up, and the impact of that on Earth's environment is something that is not new. And you have seen how it has progressed through the UN FCCC and the Kyoto and the Paris agreements and all of that entire genre, where I think India is very actively involved with the WMO, the Global Climate Observation System. And I think many countries are. So when you're thinking about sharing data and you're talking about environment, yes, there are international organizations doing that and countries are plugged into it. But what you're looking for in terms of commerce and so forth is not necessarily environment, but also importantly. But for example, you're looking for ships going up and down. And if you're looking for ships, then you're looking for the ice. And if you're looking for the ice and the ships, you're looking for oil spills. And so one connects to the other. But if you're saying, is there one set of satellites that are looking at all of those things? I don't know. Perhaps there are. I don't know whether Copernicus has, everything in it. But then you have also got countries which have got setting up different constellations for each one of these for the Arctic. And typically what happens under the international framework is that the sharing of remote sensing data, it is governed principally under what we call the remote sensing principle of 1986, which says that so you have the sensing state and the sensed state, and that the sensed state shall be provided on a non-discriminatory basis and at a reasonable cost. The primary data, the processed data, and the analyzed information. In other words, the data that derives from those satellites are the sovereign property of the state, if that is their satellite or the commercial company. So whether you have a situation, and like you said, you want to be sharing data sets to precisely which?
The sensed, the last one.
Well, which is the last one?
Again, yes.
So the point is, it's either a bilateral agreement or multilateral agreement or international, but catch all, no. Thank you.
Dr. Dimri?
Yeah, working in Antarctica from 1983 and in Arctic from last year. There is a Indian treaty agreement is there, particularly for Arctic and Antarctic also, if I am not wrong. And under this treaty, these data exchange policies are there. Maybe barring a few factors, I cannot say 100%. I have to dig with the nodal agency NCPOR, who handles treaty of India with Arctic Council and Antarctica. With my experience with working in these two continents, very oftenly we find that the data is easily available for research particularly. As far as coming to the remote sensingly available universe eye data, they are mostly web-free data coming from NASA, SWARM satellite, polar orbiting satellite, MABEN satellite, and those data is available for the purpose, for the scientific question, with various scientific institutions or scientific PIs are working for their publications. Coming specifically with certain kind of instrumentation propriety in case, there could be certain kind of writer to have a data policy on certain sense as conceived by the council, where we can have these exchanges possible. So for different research, different agenda, different scientific questions, data which is collected by various experimentalists or various PIs, they are, at least in Antarctica I know, through NCPOR you share data very amicably, and definitely it will be at the Arctic Council, but I am limiting my comment to the scientific exchanges. There may be many kind of other secret or other kind of deliberations where, so I am limiting that comment. Thank you.
Thank you. Thank you. Martin?
I think it's all about the willingness to share this data, because the data is there. There are loads of data because we have all these new sensors like radar imagery, optical imagery. We have sensors to monitor greenhouse gases. You have some freely available data sets throughout the Landsat program. US, you have Copernicus, which is owned by the European Space Agency. They have some satellites. The main challenge with those is that you cannot task them. You cannot ask those satellites to acquire an image here and there. They're like pre-programmed for a couple of weeks, but you can use them freely available. If you want the full picture, you would need to use commercial data sets as well, commercial satellites. Those who own those satellites don't send them up for nothing. It's a costly effort to launch a satellite with a highly expensive sensor. So I think it's all about also the funding opportunities for this. We have been working on a long program now called NICFI. That's a monitoring program of all tropical rainforests in the world. That's been funded by the Ministry of Climate in Norway for some years now. But what it does is it gives the opportunity for all kinds of users, ranging for indigenous peoples to agencies, governments, private industry, to download this data for free. Those are data that are being updated every single month. High resolution, 3 to 5 meters resolution, to look for illegal deforestation. So this program has been a success with more than 35,000 registered users throughout 97 countries. So if you can do some of the same, find the same funding opportunities to be able to share data, let's say from the Arctic, because as my panelists here also mentioned, oil spills in the Arctic, vessel accidents in the Arctic. With the more traffic you would be able to see in the Arctic now, cruise ships in ice-infested waters, that need to be monitored. You cannot send out a drone in climate like in the Arctic. It's difficult to monitor larger areas, so the best way to do it would be by a satellite.
Dr. Ramana?
When it comes to climate and environment data, all the space agencies are sharing their data sets. For example, if you take ESA, they have climate change initiative program under which they're sharing all kinds of data sets, whatever the sensors that they have related to climate and environment. Similarly, NASA is sharing. When it comes to ISRO, we have processed all the historical data and we are disseminating it through a portal called NICES, National Information System for Climate and Environment Studies. The data is freely available when it comes to climate and environmental data. And also I would like to bring one point. There is an international charter on space and disaster management where all the 17 space agencies are members of that charter, under which if any disaster, anything happens, all the space agencies share the data, under which also there is one charter is recently called for Arctic specific hazards. So there is a data is now available, and it is, when it comes to climate change, disaster related things, the data is freely available to the community.
Yeah. Could I just comment on that? Yes, you're right about that. The main challenge with some of these charters is that if you need the data as soon as possible, let's say there's an accident in the Arctic, there's a cruise ship that hits an iceberg, and you would need to maybe as often as possible, constantly monitoring this accident. The charter would only release some data, and it could be that you would have to wait 6 to 8 hours until the data is available. But if you operate in the Arctic, you might need that data much sooner. But as you said, yes, ESA has lots of climate data available. But if you need near real-time data from several sensors, that's a different picture.
So that's what he was mentioning about the continuity of data.
Yeah,
right? You want to emphasize on that aspect?
Yeah, I did it. So at the beginning, you
Yeah.
need the continuity of the data and how soon we can acquire the data. Most of the space agencies, they wanted to release real-time data, but there are some gaps where the data transfer from, for example, from Arctic to India, we have to transfer, we have to depend upon KSAT. And then now ISRO is heading this charter this year onwards. So,
To the audience, why is this discussion so unique is because, number one, throughout the day, we've been talking about the 3 poles of this planet. So the North Pole, the South Pole, and the third pole, which is the Karakoram Himalaya Hindu Kush tract. I must tell you that do notice this fact that you can't do any kind of economic activities in Antarctica. It's bound by the Antarctic Treaty System. What you can do at most is scientific research, be there, send your scientists, let them station in the swanky spaceship-like research stations that you've set up. That's it. You can't do much in the entire Himalayan belt, especially the glacial-laden belt, because it is humanly impossible to carry out any kind of such activities. What remains open to economic activities is the Arctic. And that's the reason why this entire conversation acquires great significance. So my next question to the panel would be, again in the same order, that in 2032-33, the world will be celebrating something known as the International Polar Year. Uh, this has been happening for almost 100 years. The last time that I remember recently writing about something was the International Polar Year of 1932-1933. Imagine since then, scientists from all over the world have been gathering and celebrating this particular year as the year of polar sciences. Again, there is this new opportunity coming up, and we are sitting here discussing in this forum what are the new avenues for, let's say, scientific players, commercial players to come together to ensure that this International Polar Year does something, comes up with certain mutual understandings that would ensure that the environmental pristineness. I don't think pristine is it's a politically loaded word, but
Let's use the dictionary meaning.
let's use the dictionary meaning, not the exact meaning. What would it take for us to ensure that even if we do carry out economic activities, we ensure that the Arctic region doesn't suffer? So, can you think of something on those lines?
Shall I suggest something?
Yes, ma'am.
Well, I draw inspiration from India's startup companies. And the fact of the matter is that as a result of our policy, we are encouraging startups to also come up with some solutions for these extremely concerning challenges of the climate change and the impact on this pristine environment and the rapid melting of the ice and how much of a change it's causing to all the regions of the world, because now you have a third pole as well. And so I'm wondering whether we could have some synergy between startups in all of these areas, in the Arctic, for instance, and ours, and for other countries that have startups, and see how they can collaborate to create better solutions and to create better economic opportunities for both parties, or for all parties concerned, if that is the way.
That's a
one
wonderful
thought.
suggestion, ma'am.
That's one thought.
Yeah.
Yeah.
Dr. Dimri?
As far as economic balances are concerned, various dialogue on north-south, south-south internationally is going on. How these dialogues are linked with the potential exchanges of the uses from the respective exchanges, from like opening of the Indian Association, the Space Association, which is giving opening for young maybe startup for sending a microsatellites, particularly in the space for a specific causes. You can have twin satellite model. People are working for magnetospheric mission. We are working for a magnetospheric mission with ISRO. So there are plenty of players which has opened up to participate as far as its final economic usages, in particularly realms of the science, which I am talking, that how these kind of things are happening, and particularly the Norway audience, they know the aurora borealis, right? In 1859, it came down up to Mumbai, and Mumbai was lighted for 3 hours in the evening. So the magnetic field became so weak that cosmic and galactic particle entered up to that week. In Mother's Storm in 2024, May is another example that. So now these all storms which are linked to the Arctic, particularly aurora borealis, has a huge impact. You have a transformer burning, your communication goes off. If you don't have a magnetic, if you have a frequency modulation goes off, your mobiles will stop working. You will not get to know where north is. In Silver Storm of Canada, this has been seen that how these, so they are very, very important economically, in particular when it comes to impact the society. So that is what I think from my way of understanding, that how we are going to, another impact as sea level rise is directly linked to the peripheral melting of the Arctic. So if that is happening, it has all secondary and tertiary order of impacts, particularly leading to economy. If your cities, coastal cities are getting gone off, a part of Bangladesh has been dying, a part of Maldives is dying, Mauritius is, so it has a kind of a secondary order cascading economic impacts. Similarly, if warming is happening, we found that from upper atmosphere, satellite-based observation, we find that upper atmosphere is a sudden stratospheric warming. So 10 hectopascal, roughly 100 kilometer up, your atmosphere is warming. So once your atmosphere is warming, your vertical at complete column of the atmosphere will has a different kind of ramification. So it will have an impact on Arctic, it will have impact on the surrounding. As I mentioned in my very first thing, we are talking on a very, very integrated coupled system, ocean, atmosphere and ionosphere. So this complete coupled system, in particular in satellite A's, will give us lot of amount of information to assess in advance that we can have how much impact.
So you want to add upon the International Polar Year, what kind of contributions?
See, from
IIT
the
will-
International Polar Year, or this year is International Glacier Year, see, these are kind of a intertwined things where in pole, particularly when we are talking, so whatever I am comprehending, here I am talking limiting not to Arctic, similarly it is Arctic also. So these all of signature has gone to the next level of observation, where you are talking of these observation from space eye, that how we have to go to the space, because there are a lot of churning needs to go, and India has in particular opened, maybe Ramana will tell better, opened its launching pads, I think, where the private small agencies can think of sending a satellite from that point. So there is an economic impact indirectly when they are coming into the market. They have indirectly impacting to the market. They can come with a startup, they can come up with their own launching thing, and then data can be comprehensively provided for all these kind of calculation. Disaster can be avoided in advance. You have, if not forecast, you can have a precursor of the aurora borealis coming to Ladakh region. Very recently we saw that Ladakh is glowing in aurora. So it means that foreign particles are coming. And secondly, it will have a health impact. I am told that these galactic cosmic particles, which are coming on the Nordic or the Scandinavian countries, they have the health issues because they are foreign particle, not good for health. Because if there is no magnetic field, we cannot be alive. All atmosphere will be sucked up. That's what is happening in the Mars. There is no magnetic field. So all atmosphere gone. So magnetic field, if goes weak and you have a satellite observations, they have a lot of economic implications. Yeah.
Perfect. Martin?
As I can only speak on behalf of my industry, being the satellite industry, but I mean, it's all about the toolbox, right? With more sensors to be able to monitor such a, it's a large area, and as everybody's been talking about throughout the conference, what happens in the Arctic doesn't stay in the Arctic. So be able to maybe even closer monitor what is happening there. You will see more traffic, you will see more exploration, probably. So how to deal with it, how to be able to make sure that industry is compliant with what is expected from them.
So that should be the target for the International Polar Year.
Maybe?
Maybe?
Yeah,
Okay.
I think so. Yeah. Like I can add to that let's say the Norwegian oil and gas industry, which is close to the Arctic, it's mandatory for them to report back to the authorities that they do this in the cleanest possible way. And the way they do it is by the use of satellites. Every single day, they're looking for oil spills outside of the Norwegian continental shelf by the use of satellites. If an accident, it's been reported back to the authorities as soon as possible to be taken action.
Dr. Ramana?
Polar Space Task Group, as a PSTG, was established under Committee on Earth Observation Satellite, CEOS, which is a body under WMO. If I understand correctly, up to 25 is the planning phase, and 26 onwards is the execution, IPY. So right now, a lot of churning is going on, and a lot of documentation preparation is going on towards how all the space agencies can come together and help to plan this IPY and all. So those discussions are going on, and documentation preparation is going on how to plan in that regard, NISAR and all these spaceborne ESAs, Sentinel series, all the data we are going to use it, 26 to 32. That's the plan is going on. PSDC is very seriously working on this, the CEOs. We have series of meetings are going on that.
Any thoughts about how can we, with the efforts of this kind that we have invested in, how can we plug into the task force that you're talking about?
Yeah, once all the space agencies, finalize the draft version and all, and then all the bodies join together, I guess. That's how the total plan is being being planned now. Everybody becomes part and partner of that overall umbrella, I guess.
Thank you, thank you. So we have another 8 minutes, and audience questions.
Just a couple of points in terms of questions that you asked. I think one of the recent events, there's a ministerial meet on science diplomacy in UNESCO, and the director of UNUSA, the UN Office for Outer Space Affairs, gave the case study of UN Spider, which seems to be a very interesting program, which, or at least helps developing countries get access to science data from satellites. So I think that's something that we could look at. Apart from UNUSA, I think the second thing on the IPY, recently at the Arctic Science Summit Week in Boulder, there are a couple of older members who were present during the International Geophysical Year, 1958-59. And they were still around, and they said that we don't know what we did right, but that laid the foundation for the Antarctic Treaty and the cooperation in space. So if we can replicate something of the 58-59 geophysical year in 2032-33, I think that will be phenomenal. Those are just 2 points that I wanted to add.
Yeah. The International Geophysical Year was also the year of the Sputnik movement. So the question would be that, are we expecting a Sputnik movement again in 32-33? Maybe this time from the polar year perspective. So a lot of possibilities, and perhaps there is great scope for even non-Arctic countries to participate in these conversations, in these discussions and initiatives. So yeah. Any other questions? Yes, sir.
Yeah, just a comment, because there was suggestion here that Arctic is important because not much can be done in Antarctica and high altitude Himalayas. Those of us who travel into the Himalayas have realized that even very high altitude in glaciated terrain, significant amount of commercial activity is going on in these days. So you just look into the hydropower plants being built extensively in a region which is very close to the glaciated terrain. In addition to that, if you look, like that is the Rishiganga hydropower plant, which we lost a couple of years back, is in the middle of glaciated terrain, very high altitude, and there are numerous such hydropower plants are there. In addition to that, if you look into the highly commercial activity like tourism, we have Kedarnath, Badrinath, we have Amarnath Yatra, that way deep into the high altitude regions. So there's extensive development activities going on. No doubt Arctic is important, but Himalaya is also equally important for us in a commercial point of view.
Yeah, that's a wonderful point. But can we place tourism and, let's say, shipping, which is a highly emitting industry, in the same bracket?
If you're thinking about pristine,
Yeah.
I think you would go cautiously.
Yeah.
I feel tourism, because it generates a lot of money for local people. So therefore, as a commercial point of view, it is much more valuable for local people. Shipping may be valuable for big companies, but for local people, tourism is very valuable.
Okay, point fairly taken. Okay, I have a question right now. So we didn't touch upon PNT satellites. We didn't touch upon communication satellites. Now, these two again are quite crucial when it comes to any kind of economic activities happening in these far north regions. Any views on that? Any views on Starlink or similar services that are offering services in these?
Well, as far as PNT is concerned, I think that the EU, I mean, Galileo, and the GLONASS and the Beidou are quite capable. And I suppose the United States also has its satellite systems, but I think NASA and NOAA and so forth. So these three systems most certainly are dealing with. Perhaps you might know about the communications.
Yeah, Martin, go ahead.
Yes, you mentioned Starlink. We also have a new Norwegian mission now with 2 satellites called Arctic Broadband mission. They have quite a strange orbit because one of the satellites will be over the Arctic and for a long time, while the other one is orbiting underneath the Earth. And then they change places, so you will always have broadband with these 2 satellites. They were launched a couple of months ago, I guess, or 3 to 4 months ago. So I guess we will see more of them as well. Starlink is also not that new, and then we have, of course, Iridium. Then you have some regulations on how they can be called communication satellites in the Arctic for search and rescue, meaning they have to have a certain percentage of online on them. This has not been tested for the Arctic Broadband mission yet, but we'll have to wait and see, I guess. But we see a movement there as well.
So do you mean your 2 satellites would do exactly the same job as the whole constellation of Starlink?
I think that's way too early to say, but as one of them will hover over the Arctic while the other one is turning around, we'll see.
Yeah, that's actually a sustainable, alternative to Starlink in that sense.
Sounds workable.
Sounds workable, yeah.
And also, I think that Iridium and OneWeb and Starlink are expanding, as I understand, their service for the Arctic as well.
See, when you are talking of communication, you are talking of physics, okay? Last decade, you might have seen many FM radios has come. So when you are talking of communication, you will see you are talking on the frequency modulation of the wave propagation, or you are talking of the amplitude modulation of wave propagation in communication way. And in last decade, all these satellite communication, in particular mobiles has come here, many kind of frequency bands has come here. So that propagation of wave in either frequency or amplitude doesn't matter. This propagation of wave, when you are talking of the satellite coming from top, and this is well designed and it is propagating. The only problem is coming when your satellite channel, the wave propagation is broken. In particularly, you many times listen a lot of noises, right? If you have a kind of cloud coming in between, you have some channel breaking, you have a thunderstorm, you have a lightning, and then you find that there is, so now the people are talking of that, how this disaster, particularly in case of wave propagation, when you are emitting and when you are receiving it back, how much time lag can be made faster, in particularly disaster time. That is one of the important thing. And second thing, extending to Professor Kulkarni, suddenly there is a more tourism is going on in space. People are working on that space debris. That is another problem coming in due course of time, that if your satellite is exiting the Earth's space, in the free space, then how it can be exited if there are multi-space debris are coming over there. So they are also constellating around, hovering around. So these are the fields which are evolving in time. So communication is getting stronger and stronger, and simultaneously satellite propagation in this space is also getting. So definitely communication.
Yeah, that's an excellent point. That Arctic, it might be devoid of ice as we are envisaging it, which is not a good sign at all for any of us living on this planet. But it may not be devoid of a cloud cover, and that is going to make Earth observations in that particular geography extremely difficult. And for that very reason, a lot of innovation will stem out when we pursue observations, PNT, as well as communication applications for the polar regions, especially starting with the Arctic. With that, I'll close this session. Thank you all. You've been a lovely audience. You've been a lovely panel for this session. Thank you so much.